In continuation to my previous video lecture of second order linear homogeneous recurrence relation, in this video lecture I will discuss the second case when the roots are complex. Okay, so we know, okay, let me write the recurrence relation of second order. So the second order recurrence relation will be in the form of, okay, Cn an plus Cn minus 1 a n minus 1 plus Cn minus 2 a n minus 2. So the recurrence relation will be in this form. Okay, and from this we have to write the characteristics equation, and that characteristics equation will be nothing but the quadratic equation. So the characteristics equation will be Cn r power n plus Cn minus 1 r plus Cn minus 2, and this is nothing but the quadratic equation. So this is characteristic equation, and this is nothing but a quadratic equation. Okay, so in my previous video lecture I discussed the first case, so when the roots are real and distinct. So now I will be discussing when the roots are complex roots. Okay, so let us take one example. If I say, okay, an, solve the given recurrence relation. An is equal to 2 an minus 1 minus an minus 2 for n greater than and equal to 2. Okay, and given that a0 is equal to 1 and a1 is equal to 2. So from this, okay, we can also write it as an minus 2 an minus 1 plus 2 an minus 2 is equal to 0. So this is the second order recurrence relation. Now for this recurrence relation I need to write the characteristics equation. Okay, so if I have this recurrence relation, from this I can write this characteristics equation. Same way for this we will write, okay, the characteristics equation will be r square minus 2r plus 2 is equal to 0. So this is the characteristics equation. Now we need to and this is a quadratic equation. We have to find the roots of the quadratic equation. So the roots will be, we cannot directly find the roots, so we have to apply Sridharacharya rule. So it will be 2 plus minus, so it is minus b plus minus b square minus 4ac. So 4 minus 8 upon 2. So when we solve it, we will get 1 plus minus I. I hope you people know how to find the roots of the quadratic equation. Okay, so quadratic equation is will be in the form of ax square plus bx plus c. Okay, so this is the quadratic equation. So Sridharacharya rule, it is minus b plus minus, okay, plus minus under root of b square minus 4ac. So b is this, and then a and c, a is 1 and c is 2. Using that we will find the roots. Okay, now you can see 1 plus minus I, so this is the complex root. Okay, so complex root, let me write the solution for the complex root. So if the roots are complex, okay, when we say the roots r1 and r2 are complex, okay, then r1 is in the form of p plus iq, okay, and r2 will be in the form of p minus iq, right? So we'll say the an is r power n, okay, a cos n theta plus b sine n theta. Okay, so this is the solution to the recurrence relation. Now we should know what is r. This r is not root. R1 and R2 are root. This r is not the root. Okay, so here we are saying a and b are, this capital A and capital B are arbitrary complex constants, and this r is nothing but r1 and r2. and this is p square plus q square. So we know r1 is p plus iq, r2 is p minus iq. So how to find this r? It will be p square under root of p square plus q square. And how to find this theta? Theta will be tan inverse q by p. Okay, so we have to, once the roots are complex, we have to find the value of theta using this value of r, and then we have to substitute the values in this equation. So this will be the solution of the recurrence relation. So now using the same concept, okay, I can write an is equal to r power n and a cos n theta plus b sine n theta. Okay, and this is suppose equation 2, and then okay, we need to find the value of r and theta now. So r will be under root of p square plus q square, and here the roots, okay, we will say this is not root, this is, we'll say r1 and r1 and r2. Okay, these are the roots r1 and r2, and r is under root of p square plus q square. So what is p square plus q square? It will be 1 plus 1. So r will be, r is nothing but mod of under 1 plus minus I. So this will be under root of 1 square plus 1 square, and that will be under root of 2. And theta will be tan inverse q by p. So q is also 1, p is also 1. So 1 by 1 will get 1 only. Okay, so tan theta is 1. So theta will be, so that way we can say, okay, theta is 45, and 45 is nothing but pi by 4. Pi is 180. So 180 by 4, it will be 45 only. So now we know the value of theta, we know the value of r, and that value we have to substitute in the equation 2. So let me write the equation again. An is equal to r power n a cos n theta plus b sine n theta. That was equation 2. And r we got under root of 2, and theta we got pi by 4. Okay, so then an will be, r is under root of 2 power n, and then a cos n pi by 4 plus b sine n pi by 4 we'll get. So this, okay, we say equation 3, and then next thing is we need to find the value of a and b. So the value of a and b, to find that we should know the initial values. So initial value, it was given a0 was 1 and a1 was 2. These two values were given to us. Okay, so using that we will find the value of a and b. So in equation 3, okay, in equation 3, if I put n as 1, okay, we get a1, sorry, it is 0 because a0, right? So n as 0, so we get a0 is equal to under root of 2 power 0 a cos n, n is 0 pi by 4 plus b sine 0 pi by 4 will substitute. So with that, okay, and similarly this is suppose equation 4, and n as 1 if I put in equation 2, equation 3. In this equation, if I put n as 1, so I'll get a1 is equal to under root of 2 power 1 a cos n is 1, so a cos pi by 4 plus b sine pi by 4. Okay, so then both the equation, if I solve, this is equation 5. So solving 1 and solving 4 and 5, we will get the value of a and b. So here in this, see, cos 0 and sine 0, here this we should know the value of cos 0 and sine 0. So this whole thing will become, sine 0 is 0, this whole thing will become 0, and then under root of 2 power under root of 2 power 0 is again 1 only, and a0 is 1, so a value we will get as 1. And then from this, okay, this will be under root of 2 power 1, a cos pi by 4 plus b sin pi by 4. So we'll get 2 is equal to a plus b. So we'll get, okay, this we will get as a as 1, and the second one we'll get a1 is 2, no, so 2 is equal to a plus b. So with that we will get a as 1 and b as 1. So once we get the value of a and b, we have to substitute in the equation 2. So an will be r power n, and r is, okay, under root of 2 power n. A is 1, so cos n uh, pi by 4 plus b is 1, b is also 1, so it will be sine n pi by 4. So this is the final solution of the given recurrence relation. So hope the concept is clear to you. Thank you for watching.